Good day to you. This is teacher LELAND, Alejandro. We're going to discuss now natural logarithm or base E, and this will be involving logarithms with the base E. That will be a natural logarithm. And base E is equivalent to 2.718281828. So we shall see the problem set on the other screen. Okay, so let me locate that. It's over here. Okay, it's in number 6. We're supposed to start it out. We're supposed to start this out in the first number, and let's see the total of this. All right, logarithm with base E, and how many numbers? We shall see how many numbers first. It's about 12 numbers. Okay, 12 numbers. All right, so we'll be solving 12 items here. All right, let's view it in the presentation view. And here's the first question. Okay, here's the first question. Solve each equation, round your answers to the nearest 10,000. Okay, 10,000. That means 4 numbers after the decimal point. Now, to explain the base E, let us start with the base E. The letter E that you see there, we're not solving for E there. We're solving for X. Okay, E is supposed to be a constant. The natural logarithm base, and this is equivalent to 2.718281828. There, that's the base E. So it's a constant. That will be the base for natural logarithm. All right, so we shall solve this equation, right? And given equation is e to the 10x, where after the value of x here, so you have e to the 10x plus 10 is equal to 36. First, you copy the problem. Next step is isolate the term with the x. We shall subtract 10. The right side becomes 26. And what remains at the left will just be e to the 10x. There. Okay, so we shall apply natural logarithm to both sides. This will now be ln of the e to the 10x equals ln of 26. There. And so ln and the e are inverse functions. And so it follows the rule in logarithm, okay? It follows the rule in logarithm. Logarithm of b to the x to the base b is x, okay? We still remember this property. And so if we have logarithm of e to the x, base e, which we don't usually write, all right? This is also equal to x, there, like that. So that means ln of e to the x is x, like that, okay? So every time you encounter like this, okay, that expression is the equivalent. All right, so let's clear the properties there of logarithms, and let's continue with the solution. Okay, so for the next step here, this is going to be just 10x. Remember, that's the expression there, ln of e to the 10x. So whatever is there, that will be the equivalent, okay? All right, so this will now be 10x, and this is equals ln 26, there. And so we're going to divide both sides by the 10. We divide by the 10 and divide by the 10. And so x is equivalent to ln of 26 over 10, there. And we shall calculate this. We use a scientific calculator for this, ln of 26, and then we divide by 10. And the computed value is 0.325809653. All right, we're supposed to round our answer to the nearest thousand. That means 4 numbers after the decimal point. So our final answer, x is equal to 0.3258 there. And so we can verify the answer. It's 0.3258, and we're correct. Let's continue the discussion in the second question. All right, let's proceed to number 2. All right, here's number 2. The given equation is e to the 10k plus 10 equals 91. Our variable to solve is k. So we write the problem first. E raised to 10k plus 10 equals 91. Okay, first step is to isolate the term with a k by subtraction of the 10 from both sides. The right side becomes 81, okay, and the left side will now be just e raised to 10k. All right, and so we apply now logarithm to both sides, natural logarithm of e to the 10k and natural logarithm of 81 there. And so the left side becomes just 10k, all right, 10k. The ln and the e cancel each other. They are inverse of each other. All right, and so the left side is 10k, and this is equal to ln of 81. Okay, one more step is division. Divide both sides by the numerical coefficient of the variable. So we will divide by 10. And we now have k equals ln of 81 over 10. And you can now use your calculator here. Natural logarithm of 81, then divide by 10. ln of 81, and then divide by 10. We have the answer 0.4394449155. Okay, rounding our answer to the nearest thousand, then this will be equal to k equal to 0.4394. Okay, that's it. And we shall check and verify. It's 0.4394. All right, we are correct. Okay, there, this is correct. All right, so let's continue with the third question. Let's have number 3. Okay, solve each equation. Round your answers to the nearest 10,000. Here's the given. We have negative 2 times e to the negative 3n is equal to negative 53. Okay, first we divide. Divide by the negative 2. Divide both sides by negative 2. Like that. And so the left side, we will just have now e to the negative 3n. The right side is now positive, okay? The right side is now positive. So this looks like, how much is that? 53 divided by 2. So it's the same as 53 times 0.5. That's 15 and 26. That looks like 26.5 positive. There, 26.5. Okay, let's remove our scratch pad there. All right, there. So we have 26.5 positive. We apply now logarithm. So this will now be ln of e to the negative 3n is equal to ln of 26.5. And so the ln and the e results to just negative 3n. And this is equal to ln of 26.5. All right, one more step is divide by the negative 3 now. Divide by the negative 3. Make sure you divide both sides. And n is now equivalent to natural logarithm of 26.5 divided by the negative 3. So we shall use the calculator to get that amount. This is now ln of 26.5 Then divide this by negative 3. We have negative 1.092381578. Rounding to the nearest 10,000, that will now be our n is equal to a negative 1.0924. There, okay? This is a 0, negative 1.0924. All right, that should be it. We'll check and verify over here. There's the computer's recorded answer, negative 1.0924. All right, we are correct. And we shall continue with the next number, number 4. All right, let's continue with the next number. All right, here is number 4. Okay, let's write the given. We shall solve the equation, round the final answer to the nearest 10,000. So this is 7e 3 to the minus n plus 1 equals 71. So first step is to subtract 1. And we will have 70 at the right side. And what's left at the left side is 7 times e raised to 3 minus n. And that's supposed to be one piece of exponent there. And so next thing to do is divide by 7 so that this 7 cancels out, all right? And we will just have e raised to the 3 minus n. And 70 divided by 7 is 10. Okay, so at this point, we shall apply natural logarithm now to both sides. Ln of e raised to 3 minus n is equal to ln of 10. And the left side now will be reduced to 3 minus n. And the right side will still be ln of 10. The right side is now numeric, okay? It's a real number now. All right, so we need to continue to the next step. We shall just use transposition, okay? Let us make the 3 remain there. Let's put the ln 10 to the left side, making it negative. And then the negative n goes to the right side, making it positive. There. Okay, you call that transposition. And so we now have symmetric property. If 3 minus ln 10 is equal to n, then n is equal to 3 minus ln 10. And we shall now use the calculator to get the answer. It's 3 minus the value ln 10. So just make sure you know how to use your scientific calculator. This is now 3 minus ln of 10. The answer is 0.697414907. All right. We'll have to round our answer to the nearest 10,000. This will be 0.6974. That's our rounded answer. We can check and verify over here. Okay, 0.6974 is correct. There, so this is correct. All right, let's continue with number 5. Let's continue with the next number, number 5. Let me clear the screen. We proceed to number 5. Okay, here's number 5. We copy the problem. 2 times e to the negative 4b minus 4 plus 9 equals 18. All right, so we shall isolate the term with a b. So we subtract 9. And right side becomes 9. That's 18 minus 9. The positive 9 and the negative 9 cancels out. And the left side will just be 2 times e to the negative 4b minus 4. Okay? And so we divide next by 2. Divide both sides by 2 so that we can simplify further. The 2 cancels out. Left side is now just e to the exponent negative 4b minus 4. And this is equal to 4.5. There. 9 over 2 is 4.5. Now we apply logarithms now. So logarithm here and logarithm there. Okay, and so the left side will be reduced to the exponent negative 4b minus 4. And this is now equal to the numerical value ln 4.5. There. Next is to add 4 to both sides. We will add 4 to both sides. So let's just put a space first. Let's put a space here. So we're going to add 4 to both sides. Plus 4 here and plus 4 here. All right. So this 4 and the negative 4 cancels out. We will just have negative 4b, which is equivalent to ln 4.5 plus 4 is the same as 4 plus ln 4.5. Remember, this is one number plus 4. Okay, so we can interchange them so that we can write it 4 plus ln 4.5. It won't matter. All right, so next line will be, okay, we have the negative 4b equals 4 plus ln 4.5. The final step is dividing by negative 4. Negative 4 and negative 4. And there we have the b. The b is equivalent to 4 plus ln 4.5 divided by negative 4. So if you're going to compute that, we will have ln 4.5, then we add 4. The value there is 5.5. 0.40777397, dividing this by negative 4. And the final answer will be divided by negative 4. And we have negative 1.376019,349. And so B is to be rounded to the nearest 10,000. This will be negative 1.3760. That's it. Negative, okay? Negative 1.3760. Final answer. All right, let's check. There. And we are correct. All right, that's for number 5. Let's continue with number 6. How about number 6? All right, here's number 6. All right. Okay, we have negative 6 raised to negative 10x minus 9. This is one piece, of course. Okay, minus 2 equals negative 76. Now, we can remove the negatives, okay, so that this is also equivalent. 6 times e to the negative 10x minus 9 plus 2 equals 76, okay? Just removing all negatives for the terms. And so we can start now by subtraction, okay? Subtract by 2 there. And the right side is 74. And the 2 and the negative 2 is 0. We have the right 74 and the left is 6 times e raised to the exponent negative 10x minus 9. There. So next step is divide by 6. Both sides. And this 6 cancels out. The left side becomes e to the negative 10x minus 9. And the right side will be, how much is that? 37 over 3. reducing it to lowest term, okay? Dividing 74 by 2, that's 37. Dividing 6 by 2, that's a 3. All right. After which, this will now be applying logarithms, ln of the left, ln of the right, there. And so the left side will be simplified to its exponent negative 10x minus 9. The right side remains ln of 37 over 3. There. Okay, so at this point we will add 9, okay? So that we will isolate the x. Add 9 here and add 9 there. And so the next step will now be just negative 10x. Negative 10x is equivalent to ln 37 over 3 plus 9. There. Okay, so at this point, we shall divide by the negative 10 to get the final answer. So we divide this by negative 10. And x is equivalent to, all right, ln 37 over 3 plus 9. Divide the equivalent of the numerator by negative 10. And so x will be equal, that must be, all right, computed by the calculator, ln 37 over 3. And then we add 9. And then we shall divide by negative 10. There. And so the final answer is negative 1.151230562. There. And so rounding this to nearest 10,000, this will be equivalent to negative 1.1512. There. That should be it. Let's check and verify. There, it's negative 1.1512. All right, we're correct. We shall continue with the next number. Number 7. All right, here is number 7. ln x plus 3 minus ln 3 equals 3. Okay. All right, this will involve logarithms. So we shall write the problem ln x plus 3 minus ln 3 equals 3. All right. We shall simplify the left and simplify the right such that both have the logarithms, okay? Now, you can see a minus here, okay? A minus. This means the expression x plus 3 is to be divided by 3. We can rewrite this by using the properties of logarithm. This will have to be expressed in a single logarithm like this. There, that's equivalent. Now, the 3 in the other side can be written using ln of e to the 3. There, you can write it that way, all right? Because ln of e to the 3 is 3, okay? All right, so we can rewrite it such that we have logarithm symbols in right and left side of the equation. All right, so we shall continue. Let me remove my writings there. All right, we can now just drop the logarithms, okay? The ln and the ln, and the equation will now be reduced to just x plus 3 over 3 equals e to the 3, like that. E raised to power 3, all right? E to the 3. Now, next is we're after the x. So we shall remove the fraction there by multiplying 3 to both sides, okay? So I will multiply this by 3. I will multiply the right by 3, like that. And so this cancels out with the 3 there. The left side will just be x plus 3. And the right side is 3 times e raised to the 3rd. All right, one more step, subtract 3 and subtract 3. And x is equivalent to 3 times e to the 3 minus 3. Okay, there. And we're not supposed to get the answer in decimals. Okay, all right, there's no instruction. This is the exact value. Okay, 3 times e to the 3 minus 3. But if you're asked to get it in numbers, you can easily get that, okay? Because e is a number, okay? You simply do it this way. 3 times 2.718, 2818, like that, raised to 3 minus 3. It's something like this, and you'll be able to get the answer, all right? Okay, yeah, but we're not required to get that. You'll be able to get that numerical value. This is just the equivalent. All right, let's check and verify. There, the answer is over here. That's 3 times e to the 3 minus 3. All right, we're not asked to get in decimals. All right, just solve the equation and that's it. All right, we have the equivalent algebraically. Let's proceed to number 8. Let's have the next one. All right, here is number 8. We have to copy the problem, ln 5 x squared plus ln 9 equals 4. Okay, this is a sum of logarithms. So that means we can multiply the 5x squared and the 9. So that we can have ln of 9 and multiplied by 5x squared. Like that, okay? And so we can also make use of the ln of e to the 4th, ln of e to the 4th, because ln e to the 4 is equal to 4, okay? At this point, we can now ignore the ln's, okay? That means we have 9 times 5. Let's just make that 45. 9 times 5 is 45. This is 45, x squared equals e to the 4, removing the ln's. And so we shall divide by the 45 here, and we'll be able to have the x. Divide both sides by 45. And this cancels out. We will now have just x squared equal to e to the 4 over 45. Now we shall apply square root, okay? Square root. So the square root and the square root, we have plus or minus value. And so this next line here is just x, okay? And we have here plus or minus. We can rewrite the square root of e to the 4. That will be e to the 2, okay? There. And then we have the square root of 45 at the bottom, okay? The square root of 45. And we can split the 45 to square root of 9 and square root of 5. Like that. And so we can continue here like x is equal to plus or minus e squared. Square root of 9 is square root of 9. And we have there times the square root of 5. We can multiply and rationalize this by multiplying the numerator and the denominator of square root of 5, like that. So that the next line, we will have plus or minus e squared, square root of 5. This will now be square root of 9 and square root of 25. And this will give us plus or minus e squared, square root of 5. The square root of 9 is 3. The square root of 25 is 5. And they are going to be multiplied so that we will have a final answer of plus or minus e squared, square root of 5 over 15. There. That should be it. There. That's 15, okay? So we have plus or minus e squared times square root of 5 over 15, okay? So that should be it, all right? So the answer from the computer is e squared square root of 5 over 15. And that's the positive, okay? And we have the other one after the comma, okay? After the comma, there, all right? We have negative e squared square root of 5 over 15. That means plus or minus, okay? Plus or minus. So you can see there are two. This, that is represented by our positive answer, and this, that is represented by our negative answer. Remember, our answer is plus or minus, okay? So that takes care of both of them. That goes to our number 8. Let's continue with number 9. Let's have number 9, all right? Okay, here's number 9. ln 3x squared minus ln 10 is equal to 1. This is a subtraction, so we can apply here ln of a ratio 3x squared over 10. And 1 can be written ln e to the 1. ln e to the 1, like that, okay? And so we can now drop the ln's, the equation reduced to 3x squared over 10. And this is just equal to e to the 1, or simply just e, okay? All right, e to the 1 is just e. There, okay? So same thing. All right, to solve this, we shall multiply both sides by 10 over 3. Multiply both sides by 10 over 3. And 10 over 3 here, like that. Why did I do that? So I can cancel out the 3 here. I can cancel out the 10. And we will just have x squared equal to 10 over 3 times e. And then we will apply square root, all right? The square root and the square root. This will now be plus or minus. And so x is equal to, how much is that? Plus or minus square root of 10e over square root of 3. There. And so we can rationalize this by multiplying it by square root of 3 over square root of 3. Like that. So we will have a square root of 9 at the bottom, at the denominator, and square root of 9 is now integer 3. Okay, so that we will not have a square root at the denominator. It says in algebra, if you have a square root at the denominator of any rational expression, then it is not simplified. So we shall turn that square root of 3 into an integer. All right, so let's just erase this part here. Let's continue there. All right, next line will be x is equal to plus or minus. Okay, if you multiply the 10e and the 3 at the numerator, this will be both under the square root. You're going to have square root of 30. Square root of 30 and e. Now the bottom is square root of 9, which is reduced to an integer. So we have here the final answer, plus or minus square root of 30e over 3, okay? So this is our roots, okay? We shall verify the answer. Okay, so these are the answers. We have the positive square root of 30e over 3 and the negative square root of 30e over 3. So that's our answer here. Plus or minus, that means we have a plus and a minus there, okay? All right, shown by the computer. There, okay? Positive and negative. All right, so our answers are correct. We shall proceed to number 10. Let me clear the screen. Let's continue with number 10. Here's the next one. Solve the equation ln 3 minus ln 3x equals 1. Copy the problem first. ln 3 minus ln 3x equals 1. All right, it's a minus, so we can express the 3 and the 3x as a ratio. So this is now ln 3 over 3x. Okay, compressing the logarithm to one single logarithm. The 1 is, of course, ln e to the 1. There. Then we can drop the ln's so that the reduced equation is 3 over 3x equals e. And you can see very well the 3 cancels out. And we will just have 1 over x equals e. All right, so we shall multiply both sides by x, okay? We can multiply both sides by x. There. And this cancels out. We will just have 1 equals e times x. And then we shall divide by the e. And this divides, and our x is equal to 1 over e. All right, and so we can write this like x is equal to 1 over e. There. And so what do we have? Yes, it's 1 over e. All right. Okay, so that goes to our number 10. Let's continue with number 11. Let me clear the screen. Let me remove the answer. Let's go to 11. All right, here's number 11. Solve the equation ln 5x minus ln 7 equals 1. Again, we have a subtraction here. Ln 5x minus ln 7 equals 1. So we can compress the logarithms as a ratio. Because it's a minus, so we can write this ln 5x over 7. Compressing it to 1 logarithm and converting the 1 in terms of logarithm, this is ln of e to the 1, like that. Then we can drop the ln's. We will now have 5x over 7 is equal to e to the 1, okay? You can ignore the 1, of course. And so this is equals, this is supposed to be equals, all right, like that. Okay, we're after the x, okay? So we can do it this way. 5x over 7 equals e. Multiply both sides by the reciprocal of 5 over 7. Okay, multiply this by 7 over 5. Multiply this by 7 over 5. Okay, why did we do that? All right. All right. So that 7 divides by the 7, the 5 divides by the 5. And so we will just have x. And the final answer is 7 over 5 e. There. Or 7e over 5. Okay? You can also write that 7e over 5. You can also write it that way. Okay? And the answer must be, what's the answer? That's 7e over 5. It's correct. Okay? All right. I believe we have 12 numbers. So we shall continue with the next, which is the final question. All right. Okay. Over here is number 12. Okay. What do we have for number 12? ln of 4x squared minus ln 4 equals 2. Again, there's a minus here. Logarithm something minus logarithm of something. We can express this or compress this into one single logarithm, a ratio of 4x squared divided by 4 equals 2. Now we can write the 2 in terms of logarithm. That's ln of e to the 2. There. And so we can drop the ln's now, and we have 4x squared over 4. You can see the 4 cancels out with the 4. Okay, 4x squared over 4 is equal to e squared. All right, you can see the 4 divides by the 4 there. And so you only have x squared equal to e squared there. And then what happens next will be square root. And square root, this will be plus or minus, and x is plus or minus e. All right, there. That means our solution set our solution set is a positive e and a negative e, like that. Okay, that's equivalent to plus or minus. Okay, plus or minus e. And we can verify that over here. There's the final answer. Okay, it's correct. You can also write it this way, plus or minus e. That completes our discussion for the base e. I think there's no number 13, okay? Is there number 13? No more. All right, so that's it. So we're done with base e, natural logarithm, and we shall continue with another lesson next time, okay? Bye-bye.